Hello, in this video we explain how we can simulate a structural model using EDAPlayground. For the structural model, remember we'll need more than one file to declare the entities that are needed as components in that structural file. So for the structural file that we'll implement, we need the NOT gate, the OR gate, and the AND gate as components, which is why we must have them declared and defined, and of course tested before we're able to use them. Remember that the behavioral file can run on its own without depending on the AND gate, the OR gate, and the NOT gate files, because we're using operators here directly. However, for the structural code that we'll create right now, I will name the file exp_struct, and don't forget the extension, it should be .vhd. I will click create file and then paste the code for the structural code. For explanation on how the code was written, please refer to the other video that I have. Now that we have the code for the structural model and we already have the files for each of the components that are needed, the AND component, the OR component, and the NOT component, we can now copy the test bench code for the structural model. So I'm going to click copy and I will paste it under the testbench.vhd. So I'll delete whatever I have here and paste the new code for the test bench. Keep in mind that design.vhd must be empty. So the test bench code will be testing exp_struct. Before I click run, or before even typing any code, make sure that you adjust all the settings as instructed. Start with VHDL as the language. The top entity must be test bench, spelled correctly, and the simulator should be LDIC Riviera. And finally, tick the box where it says Open EBWave. Now I will click run. Then you will click close and then choose Get Signals to tell the compiler what signals you want to look at. We'll choose DUT, which is the device under test, and it will show us all the signals that we need. The input ports, KLM, the output port, which is F, along with the internal signals S1, S2, and S3. I'm going to click now Append All, and then close. This will show me all the signals I need to look at, and there should be a total of 8 variations because we have 3 inputs and 2 to the 3 is 8. Notice how you have a total of 4 ports, 3 input ports and 1 output port, F, K, L, and M. These ports, if you compare them with the timing diagram you generated for the behavioral modeling that we already typed and tested in a different video, the timing diagram should match exactly, except you have extra or additional signals right here, which are to take care of the internal wiring between the components, since we use components in this file rather than direct logic operators. So make sure you verify all the cases and compare this with that you got from the behavioral model. So remember, the first step in writing, the steps that you have to follow after writing the code is to verify that the code doesn't have any errors or any compilation errors. And after running the test and obtaining a timing diagram, you should still have to look at the timing diagram and verify it to make sure that there is no logical errors in your code. If there is errors, or if you're getting an output that is not expected, then you have to go back to your code and fix it.